Review of Chapter 15. First, let's go over the double integral. Double integrals, and we know it's written in this form, a function of x and y, and integrated over a 2D domain. And we need to know how to convert between type 1 domain and type 2 domain and polar coordinate. So if you're given a domain, if you integrate x first or y first or in the r theta coordinates, you need to choose the best one. All right, let's see it by an example. Suppose you are given an integral. Well, there are two types of problems. One is you're given a domain. The other is you're given an integral. So if you're given an integral, you need to first, unless you can integrate directly, you need to figure out what is the domain first. So let's plot it in xy plane. X is the inner integral, y is outer. So y is between 0 and 1, and x is between 3y and 3. 3 is here, and 3y means this line, which is this. So that's the domain, and this is 3, 1. Okay, so what is the integral? If you do it directly, you will have a problem because e to the x squared is not something that I can integrate. But if you rewrite it as the integration of y inside, x outside, then the domain for x is from 0 to 3, and y is from 0 to, you solve for that, y equals x over 3. So this is x over 3. Then you can integrate, because integration over y has a constant for x. So you have that. Then this x over 3 will give you the u substitution that we need. So you can get directly actually, right? Because if you take its derivative, you will get 2x from the chain rule, then cancel the 6, you get x over 3. And then plug in limits, you get 6, and this is e to the 9th minus e to the 0, which is 1. Alright, so that's your integral. I mean, that's your result. On the other hand, if our domain is not so not formed by lines, maybe it's easier to do it using the polar coordinates. Let's see what kind of domain this is. This time x goes from 0 to 1, and y goes from 0 to that, and that obviously it's a circle because y squared equals, y equals square root of 1 minus x squared. So y squared equals 1 minus x squared, and that's a circle, and it's in the first quadrant. So we write it in the r theta coordinate, and x squared plus y squared equals r squared. So that's what we have. Then don't forget you have this r dr. Then for r it's from 0 to 1, and theta from 0 to pi over 2. And then this integral is pretty easy because for theta it's independent of r, so it's just pi over 2. And for r, since this extra r there, we have this u substitution, so you have negative r squared and divided by negative 2, coming from the derivative. Then plug in 0 to 1, so the result is you can factor out this pi over 4, and this negative sign can be handled by switching to 0 and 1. So plugging 0, you get 1, plugging 1, you get e to negative 1. So That's your answer. Okay, so we see that if you're given an integral, then you'd better draw its or sketch its domain and decide what's the best way to integrate. Okay, next topic is application, or we can just say center of mass, because that's our most important application. All right, suppose we have a 2D domain, and like that. Then we want to find our center of mass, x bar, y bar, right? So how to do that? You do the so-called weighted average of x and y. And this dm is the density times dA. If density equals 1, then the density, the mass is just the area. Okay. So let's see an example. Suppose you have a right triangle of side 1, 1, and then we want to find out, let's say this is origin, and we want to find out the center mass for a given density. If the density is 1, then we know the center mass is just 1/3, 1/3. But if rho is like that, then you can see it's heavier toward the hypotenuse. So the center mass will be somewhere closer to the edge, to the hypotenuse. So let's find out center mass. And by the symmetry, you can see y bar and x bar are the same. So let's just find out one of them. Okay, so what is x bar? X bar equals x times dm, which is rho dA, and the bottom is just the rho dA, and this is 2D, so it's double integral. Okay. All right, let's find out the density and mass first. Rho is x squared plus y squared, although this is like r squared, but there's no circle in the domain, so just use dx dy. Let's say we do dy dx. It doesn't matter because symmetric. So if x is outside, so it's from 0 to 1, and inside, then for each x, y is from this is x plus y equals 1, right? So then you can see this is from 0 to y equals 1 minus x, so that's what we have, right? All right, then let's just integrate. 0 to 1, and then you have x squared, it's constant, times y plus y cubed over 3, and plugging the limits, right? So you will have x squared times 1 minus x plus 1 minus x cubed over 3. All right, let's add them together. So let's factor 1/3. Then this will give you 1 minus 3x plus this is 3x squared minus x cubed, right? However, this 3 times that will give you 3x squared, so this becomes 6x squared, and a minus 3x cubed, so this becomes 4x cubed, right? So that's what you have. Okay, then you get 1/3 times 1 gives you x, and when you're plugging x with the limits, you just get 1, and 3 times x gives you x squared over 2, then plugging the limits, you get 1/2, and plus 6, and x squared gives you x cubed over 3, so you get 1/3, right? Because it's 1, we will get something pretty simple. So 4, that just divided by 4. Okay, so let's simplify. This is 1, cancel the 1. This is 2, this is 3/2, so that's 1/2, so that's just 1/6. Okay, now let's find out x bar. Not x bar, the integral in the numerator. So that's the same limit, and the only difference is that we have an x in front of the density. All right, so, and the good thing is that when this x is a constant when integrated over y, so you can just pull it out. So we get the same thing as before. If you remember, it's 1/3 1 minus, let's see what I have. 3x, 6x squared, 4x cubed. 3x plus, is it plus? Yes, plus 6x squared minus 4x cubed dx. Okay, same as before, except there is x here. But that will change quite a bit. Now I have x, then square it, you get a 1/2, right? Then 3, and then x squared will give you 1/3. Then 6, this is x cubed, will give you 1/4. Then 4 will give you 1/5. Alright, what is that? Then you have this 1/2 plus 3/2 is 2. 2 minus 1 is 1. And 1 minus 4/5 is 1/5. So you get 1/15. Okay, finally, what is x bar? X bar equals 1/15 divided by the mass. And what is the mass? It's 1/6. Oh, sorry. 1/6. And the answer is 6/15, which is 2/5. That's 0.4, and that's a little bit bigger than 1/3, as we expected. Okay, so this example shows you how to find out the center of mass. Now, let's move on to the next topic. It's the surface area. And let's say, and the volume. Because volume is relatively easy. So, suppose you have a surface in the 3D space. Then how do we find out surface area? You project onto xy plane. You know, it gets like that. So this is a domain. And your surface area would be the integration to the integral over this domain. And if you just do dA, then it's the area of this domain. But you have to multiply by this factor. So you have to take a derivative of z over x and z over y and just put in the square root. This is, you can regard this as a 3D Pythagorean theorem. Because if you have just z as a function of x, then you have this, you know, tilted, so you have a larger surface area than the area in the domain. And how about the volume? Volume is easy. It's just the height, which is a function of z, which is just z over this domain, right? So that's volume and the surface area. And let's finish our example I proposed in the class. That is, we try to find out the volume and the surface area of the domain, not domain, of the region, 3D region, bounded by x squared plus y, y squared. X squared plus z squared is less than or equal to 1, and y squared plus z squared is less than or equal to 1. Alright, so what are they? The first one is a cylinder along y-axis. So if you plot this way, you will say like that. This is the, the cylinder, and the other way is, this is the y-axis, and the other one is like that. This is the x-axis, and that's the other cylinder. So let's plot more carefully. Okay, so let me plot something along the top, and this also the highest point. So if you view from the top, then you will see you have an upper half and a lower half. So let me just plot the upper half. So you will see something like that. Right, this middle point is 0, 0, 1. So it's quite high, and this this is the square, right? X equals plus minus 1, y equals plus minus 1, and so you can see this is the thing in this square is a 3D object, and in particular this in the first quadrant, let's say this one. This is the intersection of the two cylindrical surfaces. So this one, let's say this one here, it's x squared plus z squared less than equal to 1, and this one is y squared plus z squared less than equal to 1. So their intersection must be x equals y, right? Because both equation 1 and equation 2 are satisfied, so they must be they imply that x equals y. So, and let's find out the volume first. So how to find out volume? Well, the volume, you can see by symmetry, it has the upper half and the lower half. So let's say the upper half. But in upper half, you can see it can be divided into 4 quadrants. So if you do x and y, you can see everything is in this square, right? Negative 1 to 1, and then negative 1 to 1. So let's consider what happened in this first quadrant. Okay. And this line is x equal to y. So you can see we can divide this entire thing into 4 quadrants, and actually 1 octant, because z also upside down, right? I mean upper half and lower half. So 8 times what happens in the first quadrant, or not quadrant, or octant. So in the first octant you have an x, z, y, x, y, z are all positive. But what is happening in the first quadrant? Z must be less than or equal to 1 minus x squared, according to this, right? And z must be less than or equal to 1 minus y squared. So what is z? So z is actually less than the minimum of both of them, right? So if one is less than the other, then z is less than the smaller of them. So what is the volume? It should be z dx dy from 0 to 1, 0 to 1, right? That's the volume. This 8 means there's 8 octants, but this z is, the thing we have written here. So it's kind of awkward because you have a minimum there. But think of that. When do you have the first term? When x is larger, right? When x is larger, this term is smaller, so z equals that, which means this part, right? Because this is x equal to y, so below that is x greater than or equal to y. So that's the region where z equals 1 minus x squared. And above that, it's the other way around. So if you understand that, then we can write down integral in either way. We can cut into 2 halves. And by symmetry, you can see the lower half and that half have the same volume, right? It's just symmetric by reflection about x equal to y. So what is the volume? You can just cut into, you can double that, 8 becomes 16. Then you can only work on the lower triangle. So what is the lower triangle? Y is less than or equal to x. So x is from 0 to 1 and y is only from 0 to x. And in this region, this is smaller, so it's just that. Then you have to do dy first, then dx. Okay? Alright, that's your volume. Let's integrate that. 16, 0 to 1. And how to integrate the middle one? Well, that's pretty easy because x is constant. Ooh, really nice, right? Because if you don't have this x, then you cannot do the, you have to do the trig substitution. Now it's just u substitution. Okay, so this means, so let's do the u. U equals 1 minus x squared. Alright, so this equals u to the 1/2, and this is x squared here. So you have a du over -2 from, you see, plug in limits, u is from 1 to 0, right? Because that's 1 minus x squared. And then you can change this negative sign to switch them, right? So you get 0 to 1, u to the 1/2 times du over 2. And you can factor out that, 8. And u to the 1/2 becomes u to the 3/2 times 2/3. And plug in the, plug in the limits. And then you get just 1 for u to the, I've got the 2/3 here. Then you just get 16 over 3. Done. That's a volume. Alright, and does that make sense? Yeah, because if you just think of a cylinder itself, right? So you have a cylinder cut into this part. So you have a, just a cylinder. So this is 2, and this is radius is 1. Then what's the volume? Volume equals pi r squared times 2, right? The length. Suppose you have just this part. Then that's about 6. And this is 5 point something. So that's good, right? Alright, now let's find out the surface area. That's harder, but it's still related. I mean, our stuff is still very relevant. So let's see our analysis. So we can see the surface area also has the top half and the lower half. And actually it's also divided into 8 octants. And each octant is still divided into the upper half and the lower half, right? So you can have like a 8 pieces. 1, 2, 3, 4, 5, 6, 7, 8. So there are 8 pieces, and the bottom also 8. So let's just find out the surface area of this region. Okay. So if you remember, there were 16 pieces, 8 on top, 8 at bottom, and then this is still from that. Remember, it's like this: 0 to 1, 0 to x, and this is dy and dx, right? But this is not z anymore. What is that? It's a square root of 1 plus z prime x squared plus z prime y squared. And what is z? And z equals, okay, so just plugging this z to that function, and then we're done, right? Oh, of course, we have to integrate. Okay, what is z prime x? Okay, it's a little bit complicated. It's a square root of 1 minus x squared, and you have a 2x on the top, actually negative 2x on top, but there's also 1/2 down there because of the derivative, so you have to cancel that. And when you integrate that, you get x squared 1 minus x squared. Right, and the z prime y equals 0, so you get nothing. And then you get dy dx. Okay, let's continue. So 16, and this is actually not so hard because you add them together, you get a numerator 1 minus x squared plus x squared, so you get still 1. right? Then it's quite similar actually. So you get 0 to 1, and for y it's a constant, so it's just that. See, it's very similar. We can still do the same u substitution. Then you have 16, and this is du over 2, but our u is in the denominator now. And then, oh sorry, negative 2, and u is from 1 to 0, right? So let's continue. So you get cancellation becomes 8. Then let's switch the limits, so we can get rid of this negative 1. So you get du like that, right? So this gives you 8 times u to the 1/2 over 1/2, which means times 2, then 0 to 1, and then you can plug in the limit, you get 16. Alright, so that's your surface area. Does that make sense? Let's see. If we have this surface, suppose you have this is kind of like a sphere, right? But actually the sphere would be only on a circle, not on a square. So this might be a little bit bigger than a sphere. So if you have a sphere, then what is the surface area? Well, the radius is 1, so the sphere would have a 4 pi r square, right? Sorry, r square is just 1, so this would be sphere's surface area, which is 4 pi, which is about 12. And let's see what we have. We have 16, right? And you can see 16 is a little bit bigger than 12, so that makes sense. Okay, so that's a very interesting example, and I hope you can at least enjoy that. All right, the last topic is triple integral. Okay, the triple integral is on a 3D domain, and it can be written in quite a few ways. It can be written in x, y, z, and of course you also have y, z, x, x, y, z, z, y, x, etc. 6 ways. But more importantly, we can also write on it in the cylindrical coordinate, which is dz, and r, dr, d theta. And when you write on the xyz for the f, you need to remember you have to write on r cosine theta, r sine theta, and the z. And then another way is to write on the spherical coordinate. And then you have, oh, that's complicated, rho sine phi cosine theta, rho sine phi sine theta, rho cosine phi, and this volume is rho square sine phi d rho d phi d theta. Okay, so you can see there are quite a few ways, and just like a 2D, it's depend on the problem to choose the best coordinate. And actually sometimes it's more than one way. You can choose either this way or that way. For example, let's see the next problem. For minus, and this is that to let's see, this is a 8 minus x squared minus y squared, and then xz dz dx dy. Alright, for this integral, it's a bad idea to integrate directly because you have so many square roots. Although I'm not sure, maybe it's still possible, but still it's a kind of a let's see, maybe it is possible. So because you see when I integrate that, then get z squared, and this square root will be gone, right? So actually it's not too bad. Let's see if it works. Okay, maybe it works. So you will have 0 to 2, 0 to that. Then you have x times z squared over 2, right? Then plug in two limits. So you get 8 minus x squared and minus another of them and divide by 2, and then it will dx dy, right? So then you do this, and then you cancel the 2, so you get a 4. So you get a 4x minus a couple of things. So, well, it's a bit complicated. So you get, but not too bad. So you get x squared over 2 for the 4 minus y squared. And for the x times x squared, you get x cubed, which you get x fourths over 4. Right? Just do it carefully. Then you plug in the limits. 0 to 4 minus y squared dy. Well, sorry, square root. So actually not too bad. 0 to 2. Then you plug in the square root. It actually becomes just that, right? Then square root squared and squared again, so you get this. Alright, so you cancel that, you get 1/4 of the second thing, so you can factor out 1/4. And 4 minus y squared square. Alright, so you can finish it actually. So then you get 1/4. Let's see what you get. So you get a 16, then you will give you y, then you get 8 y squared, then you get y cubed over 3, then you plus y to the 4th, so it's y to the 5th over 5, and then plug in 0 and 2. Alright, let's see what you get. 1/4, then you plug in 2, 32 minus 64 over 3, and plus 32 over 5. What is that? So this gives you 32 times 3, which is 96, minus that, so it's this. And then you have 32 divided by 4, which is 8. Then you get 1/3 plus 1/5, that is 15. Then you have 8 times that is 64. Alright, that's what you have. Remember this number, okay? Let's see if we get the same thing if we use a different coordinate. Let's see our old problem. Okay, where it's here. So let's see what kind of domain is that. Oops. Okay. So suppose this is x, y, then x is from 0. So y is from 0 to 2, and x is from, you can see it's a circle, right? Circle of radius 2. So you can say r is between 0 and 2. Oops, between 0 and 2. And theta is between 0 and half pi. Okay, so what is z? Well, this is your lower z. So z is at least r, and z is less than 8 minus r squared. Right? So let's remember this, between r and 8 minus r squared. And the r is 2, theta equals pi over 2. And the integrand is just x times z. Okay, let me try to write on. We have z, dz, r, dr, d theta, and the integrand is xz. And x would be r cosine theta, and then z is just z. And then theta is from 0 to pi over 2, r is from 0 to 2, and z is from r to square root of 8 minus r squared. Okay, so similarly, we can do the integral. And this time you can integrate d theta first. So that gives you sine theta from 0 to pi over 2, which is just 1, right? Then for dz, let's keep the r terms together. Okay. You give r squared dr, and then z dz would give you z squared over 2, and plug in two limits. let's simplify that. This is just 1. Then you have 0, 2. And then you have a 8 minus r squared, then minus another r squared, and over 2. So that gives you 4 minus r squared. Alright, almost done. So you get 4r squared, so you get a 4 times r cubed over 3. And then r to the 4th gives you r to the 5th over 5. And plugging the limits. So you get 64 over 3 minus 32 over 5. And that is, factor out 32. So you get 2/3 minus 1/5. Oops, did I make a mistake somewhere? Oh, that's wrong. This is also 32. 4 times 8. So you get 1/3. And that's 5 minus 3, which is 2 over 15. Okay, so that's the same result. Okay, last but not least, let's try the spherical coordinate. Yeah, let's see if it helps. Well, it might help because you still have this, square roots there, right? So let's see, what does that mean? Z is between R and this, right? So let's see, what does that mean? If you remember, R is less than equal to Z. So R is greater than equal to Z is greater than equal to R. It means that it's a cone, right? It's above that. So that means phi is less than equal to pi over 4. And this part means z squared plus x squared plus y squared is less than 8. Or you can say rho is less than 2 root 2. So our condition is that. Then what is our integral? Okay, so it's theta is still the same, but these two limits will be different. Right? So it will be, let's write down again. Let's say rho square sine phi d rho d phi d theta. Theta is from 0 to pi over 2. Yes, pi over 2. And phi is from 0 to pi over 4. And rho is from 0 to 2 root 2. And then what's integrand? X and z, right? X is this, and z is that cosine phi. Okay, so that's a bit complicated, but let's see. So let's see, what do we get for z? For theta. It's this and that. It's same as before, right? So you get sine theta from 0 to 2 pi over 2, which is just 1. And then for the phi, you have sine phi, cosine phi, and another sine phi. So you get, you merge it, together. So you get sine phi squared and, cube over 3 from 0 to pi over 4. And then for rho, what do you get? You get 1 rho, 2 rho, and rho squared. So you get rho to the 4th. So you get rho to the 5th over 5. And 0 to 2 root 2. Okay, let's see if it's the same. This is just 1. Pi over 4 gives you 1 over root 2. And then since it's in denominator, so it's 3 times root 2 cubed, right? So it's 2 root 2. Then this is 2 root 2 to the 5th. So you get square root is 8 times 8 times 2 root 2 over 5. Let's cancel that. And yes, we have 64 over 15. So for the third time, we get the same number. Alright, so all of this tells us that they are consistent, right? So you can choose whichever is most convenient, but it's really not unique. And let me see. So we have just done the spherical parts. So I believe you can still review by yourself, and just go over everything in this chapter, and we will have the exam next Monday. Bye. Good luck.